So have you ever left a nightclub feeling that sounds are muffled or maybe there's a ringing in your ear? Well, both of those are very common symptoms after noise exposure. What happens when we're in a loud environment is that we start producing these harmful molecules in our ear, and they can accumulate over days and even weeks. And these molecules can cause cell damage. Sadly, we are only born with about 20,000 cells in each ear that can sense sound, and these cells cannot divide and they cannot regenerate. Therefore, every time we damage a few of them, we're actually causing permanent hearing loss. So the goal of my research is to find mechanisms to prevent hearing loss after noise exposure. That is, to prevent hearing loss even if you decide to go dancing every Friday night. There is a gene that is highly expressed in the inner ear. Its name is TRPA1. And the function of this gene in this tissue was completely unknown before my research. What we know about TRPA1 is that in neurons from other tissues, it acts as an irritant sensor. For example, in neurons from the intestines, TRPA1 can be activated by spicy compounds from wasabi, garlic, and onions. And in neurons from the lung, it can be activated by irritants from pollution and smoke. And in the skin, it can be activated by inflammation. And I used an imaging technique and found that in the inner ear, these cells can use TRPA1 to detect the harmful molecules that are produced after noise exposure. So they have a built-in sensor for damage. Do they also have a mechanism to protect themselves after noise exposure? Well, to test this, we use mice that have been genetically modified and that lack the TRPA1 gene. We expose them to noise and we check for hearing loss. And we found that actually when the TRPA1 gene is absent, the hearing loss is greater. Next, I also found that TRPA1 acts as a door in the cells. That one is activated by the harmful molecules, acts as a door, and allows the entry of calcium into the cells. But how do the cells use calcium to protect themselves? Well, to test this, I'm using a light-sensitive molecule that has calcium trapped inside. I can safely deliver this molecule into the cells. And then, using a laser under a microscope, I can shine light into one cell, and this will cause the molecule to open and release calcium into that one cell. That way I can study what calcium is doing one cell at a time. Like I mentioned, the goal of my research is to find mechanisms that can protect against hearing loss, even after noise exposure. One way, for example, could be to find therapeutic targets that could activate TRPA1 before the harmful molecules are even produced. That will provide you with a layer of protection before you even enter your favorite nightclub.